At HH Corporation, I had a dream, and that was I wanted a dog, and I would do whatever it took for me to get that dog. Even if it meant I had to build one from scratch, just like Boston Dynamics. However, little did I know, it's so hard.
We all know the traditional Boston Dynamics robot dogs. They look really cool, they're kind of scary, and they look like they could take over the world. We wanted to reduce that by making the dog look more like an actual dog. We wanted to give it ears and a tail. Well, we kind of did that, and I think it looks pretty good.
Meet Rob, O-Dog. Intelligent, one-of-a-kind robotic dog based on the Boston Dynamic dog. Both cute and one day will be functional. So this is our project. What we created is a dog based on the Boston Dynamics dog, but the SpotMicro. And what we did, we added a few changes, mostly making it look more aesthetically pleasing, as our team members will later show through with the head, and we try to add a tail. It's not connected through a servo because there was a lot of technical difficulties with even just printing, but so far we were able to properly stabilize it, and we have all the circuitries. If you look over here, we have the Raspberry Pi and the Adafruit, all connected towards all 12 of the servos, and that controls the dog. So yeah.
Hey everybody, this is Jen Ellis, and I was working on the dog head. I uploaded the STL file from Thingiverse, and the head initially did not look like the dog. It was just very square and rectangular. So what I did was modify it, but I kept the basic form there of the head, but what I did, I closed off the front face by extruding a panel out, adding a nose, and then adding in 2 side ears for that.
Hey everyone, it's Ash, and today I'm going to be talking to you about the component of the project I worked on, which was the tail of the dog. So for the tail, we wanted to kind of go for a kind of a link system similar to, here I can show you, these toy snakes we used to play with when we were kids. So running with the idea, we were able to create this type of model. Now this model comprises of links and joints. The links are these long cylinders and the joints are these circular connectors that go in between them. Now the links rest against the joints and are then tied together using fishing line that passes through a set of holes in each link. And a motor is then placed inside this main shaft hole at the base.
Hey guys, this is Leon. I was working on the software team for RoboDog, and today I'm just going to show you guys kind of this open source repository that we found that works really well with the open source project that we found. So this is a separate open source library. This is actually filmed before we get this code running on the robot. So future Leon, tell us if this works. Thanks, Leon from the future. All right, so basically it came with a lot of ROS nodes that do various functionalities, some of which involve parts that were a little bit too expensive for our project, like LiDAR. So we are not going to be able to use those, but they have this really convenient servo, this keyboard move.py file, which allows us to move the robot with a computer that's connected to it just by using WASD. It'll be kind of like a video game. Pretty cool. Again, cut to future Leon if this part worked out. Okay, this is the main file. It's a lot of code that I will someday understand, not right now. But basically, this is the move commands. So this is a very nice state diagram that they gave us, that the motion command, all of these different ROS nodes that we're able to kind of coalesce into this file, which directly interfaces with the servos. and has a few transitions. So there's the standing transition, there's an idle transition. Then there's a walk, which will be triggered by a keyboard interrupt once we are SSH'd into the Raspberry Pi. So yeah, this repository and just the simulation stuff in general was extremely effective in getting us off the ground with this project. Hopefully we can get it implemented, and yeah.
Hi, so I'm here to talk a little bit more about the electrical side. So we mainly have a 7.4 LiPo battery that is the main power supply for all of our components after some conversion. And our core component here is our Raspberry Pi, which is running ROS on it. And the main issue is that it doesn't have enough driver pins for our 12 servos. So we actually need to kind of have it communicate with this secondary pulse width modulation servo driver board. It has up to 16 channels, which is good enough for our 12. And we basically just use I2C communication to kind of select and communicate to servos through the Pi.